Hello everyone. Slow down radiation. And first, in radiation, write down black body. What is a black body? Any object which is going to absorb all the radiation falling on it. All the radiation. Maybe you had the idea of this EH nu or E equals to HC upon lambda. Well, tell me first, have you seen this equation before, this relation before? Energy of a photon is Planck's constant, nu is frequency, c is speed of light, lambda is wavelength. Have you seen this thing before, yes or no? Good. So what a black body is, all the possible wavelengths falling on it will be absorbed completely. There will be no reflection at all. So if you have such a body which absorbs all the radiation falling on it and does not reflect any part of it, it's called what? A black body. Write down the definition. A black body is a body. A black body is a body which absorbs all the radiation inside the bracket, that is all the wavelengths inside the bracket, all the wavelengths. Black body is a body which absorbs all the radiation falling on it. No part of this radiation, no part of this radiation is reflected. Let's talk about a simple thing. Let's say visible light. Now, visible light is what? Vigor. VIBGYOR. Violet, indigo, green, yellow, orange, red. So let's say all the colors are falling on it. We'll say all the wavelengths. In totality, it will be ultraviolet, it will be X-ray, it will be gamma, everything, every type of light which you can think of. When I say light, any type of electromagnetic wave, and therefore any wavelength which falls on it will be completely absorbed by it. Such a body is called a black body. Now, if we have a black body, then we are interested in Stefan's law. is also called Stefan Boltzmann's law, but for us this is only Stefan's law. What Stefan's law is, at thermal equilibrium, if you place this body at some thermal equilibrium setup, then this body also radiates energy out of it. All the red arrows. Now, it is absorbing some energy. It absorbs, and then its temperature is going to increase as you have absorbed the energy. Now, when a body absorbs, it also releases that energy. So any black body, first of all, does what? Absorbs all the energy, and then the energy which it releases back into the surrounding, its rate, energy radiation released by the body at thermal equilibrium per unit time, this thing, what he found is that is proportional to fourth power of absolute temperature of the body. So this is the body, its temperature is, let's say, T naught, or let's keep it T, we'll use T naught for the surrounding. So if temperature of the body is T, then Stefan says that rate of radiation going out at thermal equilibrium is proportional to fourth power of absolute temperature, that is temperature in Kelvin. We'll write what du by dt is again, is proportional to surface area of the body, and when you remove this proportionality sign, we use a constant, and then the whole thing becomes sigma a t to the power 4. Sigma, its value is 5.67 into 10 to the power minus 8. Very easy to remember constant. 5, 6, 7, 8. That's how you can remember it. T is the temperature of body, and the body is releasing all the radiation out of it now. At some point of time it absorbed the heat, and now it is releasing the heat. So as it releases, now some of you might get confused that, sir, if it is releasing, then how come it's a black body? So what was the definition of black body? If blue light falls on it, if red light falls on it, then no part of that will be reflected back into the surrounding. Every part of that energy, if 100 joules is coming, all that 100 joules will be absorbed. Now once it has absorbed that heat, at some point of time it is going to release that energy. If blue light falls on a body and is not absorbed by it, let's say blue and red both fall on a body, blue and red. As blue and red they both fall, but blue is reflected back and red is absorbed, then that body is not a black body, remember. And that body will appear to you what? Blue in color, because red is absorbed and only blue is coming towards you. Whereas for a black body, blue, red, yellow, green, all the lights, all the wavelengths which fall on it will be completely absorbed by the body. And then at an appropriate time, when it releases the energy into the surrounding, rate of radiation released per unit time with du by dt. Write on this. What is du by dt? Rate of radiation released by the body. Rate of radiation released by the body. Inside the bracket, energy per unit time. Energy released per unit time. Now, according to Stefan's law, this rate is proportional to fourth power of absolute temperature of the body. Remember, if this body is at 0 degrees Celsius, then you do not say that it's not going to emit any radiation. 0 degrees Celsius is what? 273 Kelvin. So this T, remember, is always what? Absolute temperature. In fact, write down the statement of Stefan's law so that you remember every time concept of absolute temperature. According to Stefan's law, rate of heat radiation emitted by the black body, rate of heat radiation emitted by the black body, inside the bracket, energy released per unit time, is proportional to fourth power of absolute temperature of the body. Fourth power of absolute temperature of the body, as well as is proportional to surface area of the body, as well as it is proportional to surface area of the body. Now, forget about black body, just imagine what you have an object and take that object and remember, when you talk about black body, there is no need for it to be spherical. Any body of any shape and size, if can absorb all the radiation falling on it, will be called what? A black body. There is no requirement that it should be a spherical one or cubical one. It can take any shape. If it fulfills the requirement, as I told you, it will be called what? A black body. In fact, do mention this point also. Black body can have any shape. Black body can take any shape. Not necessarily a spherical body. You can have a cubical body, cylindrical body, anything. And as usual in physics, nothing is perfect. You will never find something which is a perfect black body. In reality, some part of that energy will be released into the surrounding. Now, just when we are at this part, du by dt is sigma a t to the power 4. From this elementary relation, we can develop a few interesting and easy questions. So let's write down a question on this Stefan's law. And what the question is, suppose we have a spherical body. कोई ज़रूरी नहीं कि spherical हो, it can take any shape, but now if we have a sphere and if we cut open this sphere into two halves, cut it, open it, then what happens to this rate? Does it remain same or it is going to change? If it remains same, then write down same in the comment box. If it is going to increase, then tell me by how much it is going to increase. If it is going to decrease, then again tell me by how much this is going to decrease, and everything is on the board. The question is, you have a hollow sphere, which is the black body for you. Now when you cut it open into two equal halves, then by what amount rate of heat radiation coming out of the body is going to change? Well, I've got only the 2-3 responses and they are correct, but I'm also asking you by how much. Now, question बड़ा easy है. Tell me first, when you cut this sphere half into two equal halves, is it going to change the area? Yes or no? Good. Everybody says yes. Just find out the change in the area. Sigma is a constant. T, when you cut it open, you're not going to change the temperature. So the whole thing is basically a function of A. If you can find by how much you are going to change the area, you can easily answer the question. So when you take a hollow sphere और आप इसको बीच में से इस तरह से कट कर देते हो, तो by how much you are increasing the area, by that much you are increasing du by dt. इतना सा क्वेश्चन है. Taking too long. Do you understand this? Initially, it is A. Finally, it is 2A. That's all. कुछ खास था ही नहीं. A and then 2A. What type of sphere you have? Hollow. What is the surface area? This. जैसे आपने इसे कट किया. What is the surface area? This outer one as well as the inner one. Now the inner one is also open to the atmosphere. This one. So how much area this body has now? This, and the other half. This and this. What is that? A outside, A inside, which is what? 2A. Since area is increasing by 2, by a factor of 2, du by dt, rate of heat radiation coming out, is also going to increase by 2 only. Do you understand this? 2, yes or no? Fast. Because not a single person could answer 2. Now let's see how much you understand this question. Answer the next part. This was a hollow sphere. Now, if I have a solid one, if I have a solid sphere and if I cut it into two halves, then by how much heat radiation, rate of heat radiation is going to change? Answer this fast. Only one person could answer it correctly. You have a solid sphere, solid. What is A initial? Initial surface area is 4 pi r square. That is initial. Now, if you cut this solid sphere into two equal halves, then can you see that apart from this spherical area of 4 pi r square, you also get circular area of pi r square and pi r square. And only one person could answer this question. This is the final setup. So in the final setup, your A final is coming what? You already have 4 pi r square, which is the curved area, spherical area. And apart from that, you get pi r square plus pi r square. So what is the change? What is A final upon A initial coming? 6 by 4. 4 plus 1 plus 1, 6. And this is 4, which is 1.5 times. If you have a solid sphere and you cut it into two equal halves, then rate of heat radiation coming out of the body is going to increase by a factor of 1.5. Only one person could answer this after telling you everything over here. And when you are talking about this, remember this is a hollow one. So in the hollow one, you don't get pi r square. You get outer curved area, spherical area, and then inner curved spherical area. Note down this. Let's see how many of you are going to answer this. We have a solid sphere, and then we reshape the whole thing into 8 identical smaller solid spheres. I hope you remember what I'm asking you. We have done something like this already. We have a big solid sphere, solid, and then you reshape the whole material as what? As 8 smaller solid spheres. By what fraction rate of heat radiation is going to increase? Now, who can tell me where we have done something like this before? In which chapter we did something like this before? Let me ask you this part first. How active you are. Good. This was done in the chapter of surface tension. We found change in surface energy. So now, since you remember the name of the chapter, let's see if you can answer the question also. Good. Some of you have answered correctly. Whenever you break a big drop into n smaller drops. So whenever something like this is done, the final area in terms of initial area, in terms of n, is a very easy to remember formula. What is A final? N to the power 1 by 3 A initial. Just remember this. And you can use the same thing in two chapters because they both are using concept of surface area only. So if you have a drop and you convert the drop into 8 identical drops, your n is what? 8. If n is 8, your A final is what? 2 times A initial. So rate of heat radiation coming out will be 2 times, because A final is also 2 times A initial. Simple use of this formula. How do we arrive at this formula? See your notes. I've already taught this thing in surface tension. Put down this. Now answer this. You have a given amount of material at some temperature T. Assume that it's a black body. But you don't want it to lose its energy. I mean, you want to minimize loss of energy. There is no way you can stop it from doing that, because Stefan's law tells us if it has some temperature T, it is going to radiate energy out of it with sigma E T to the power 4. The question is that as it is losing energy, we want to reshape this whole thing so that we can minimize the loss. Again, I'm asking you something which we have discussed in the chapter of surface tension, and therefore I need a very fast answer. The body is this. We want to minimize loss of heat radiation, what should be the shape this material, what should be the final shape of the container, you can say, the material should be kept in so that we can minimize loss of heat radiation. Answer this fast. Suppose we have stored energy coming from sun in a solar power plant, not the concept of solar plates only, a solar power plant which absorbs the energy and retains it inside of it. You want to contain the energy so that its heat can be utilized at the night time. So you want to have all the energy inside. You don't want to lose energy because of Stefan's law. So what should be the shape this whole material be kept in which can minimize heat loss? Good. Good. Answer is what? Answer is what? This material should be kept in the form of a sphere. And the reason is what? Volume is V, volume is V. Same material. And we had a statement, for same volume, surface area of a sphere is minimum. Write down this. Since for a given volume, surface area of a sphere is minimum, since for a given volume, surface area of a sphere is minimum, rate of radiation going out, inside the bracket, heat loss will be minimum for a spherical body. Will be minimum for a spherical body. Now, there are two things with this black body. Its temperature is T, that of the surrounding is what? T naught. T naught is temperature of the surrounding and T is temperature of the body. And what it does, it releases energy out of it. The energy going out is sigma A T to the power 4, and at the same time it absorbs heat from the surrounding. It absorbs heat from the surrounding, and that rate of absorption is also sigma A T, but which T? That of the surrounding. T naught to the power 4. This is going out, this is coming in. Rate of radiation being absorbed depends on temperature of the surrounding medium, fourth power. Sigma A T naught to the power 4. Area will be of the body, T naught will be of the surrounding. Heat radiation absorbed by the body is what? or is emitted by the body, emitted out by the body, is sigma A, temperature of the body. If T is greater than T naught, we are interested in this case. If T of the body is greater than that of the surrounding, then cooling will take place. भाई ये 100 पर है, सराउंडिंग 30 पर है, तो पक्की बात है टेम्परेचर क्या होगा, डिक्रीज. Temperature of the body is going to decrease. More heat radiated out, less absorbed, and therefore temperature of the body is going to decrease, which will be called cooling. We are interested in a special case of the cooling, which is called Newton's law of cooling. We can develop the concept of Newton's law of cooling, which we are going to discuss with the help of Stefan's law. But this fourth power is going to make things complicated for us when we go for integration. As temperature decreases, a continuous process, this T power 4 is going to create problems for us, and therefore we use an approximated version of cooling, which is called Newton's law of cooling. In complete form, without any approximation and all, total heat radiated out, total, it will be simply what? Sigma A T to the power 4 minus T naught to the power 4. T to the power 4 goes out, T naught to the power 4 comes in. This is the net loss, and because of this, temperature of the body is going to decrease. This is the fundamental form, but because of this, it is going to create a lot of problem when we try to integrate, and therefore we are not interested in the exact format. We are interested in something which is much easier, which is called Newton's law of cooling. But before that, note down this much, and then we'll write Newton's law of cooling. Remember, this in means radiation absorbed, out means radiation coming out. Note down this much. Write down Newton's law of cooling. What Newton says that if T minus T naught, T minus T naught, temperature difference between body and the surrounding, is very small, then rate of cooling dt by dt, drop in temperature, dt, the time interval in which this drop took place, is proportional to T minus T naught. We are interested in this statement. Rate of cooling is proportional to difference of temperature of body and the surrounding medium. dt by dt is called rate of cooling. We can arrive at this function with the help of Stefan's law, but we are not interested. If somebody is interested that T minus T naught being very small, consider the whole thing as x, put it into that sigma A t power 4 minus t naught power 4. Use binomial, open, do approximation, you will arrive over here. But Newton found this thing experimentally, and he says what if you have small temperature difference, then the rate at which temperature drops, cooling, is always proportional to T minus T naught. Write down the statement. According to Newton's law of cooling, rate of change of temperature of the body with respect to time inside the bracket rate of cooling inside the bracket dt by dt is proportional to temperature difference between body and surrounding medium. Provided this difference is very, very small. Provided this difference is very, very small. Now, let's remove the proportionality sign and let's write down a constant b. We normally use a constant b. There is no need for you to find the value of b. Why? We'll see a few questions. So when I remove the proportionality sign, dt by dt becomes b into t minus t naught. You can always arrive at b using Stefan's law, but right now we are not interested in this b. So dt upon dt is b times t minus t naught. T minus t naught is very small and we are talking about cooling. That means we are talking about T greater than T naught. Remember, T greater than T naught. Tell me, this B, is it positive or a negative number? That's what only we are interested in as of now. If we use a constant, what do you think? This B will be a positive constant or a negative constant? What do you think? Some are saying positive, some are saying negative. I'll give you a hint and you can yourself decide. Whenever we go for dx, dy or anything like that, it is always final minus initial. This is a hint. Any type of d is what? Final minus initial. That means when you write dt, it will be t final minus t initial divided by t final minus t initial. T final minus t initial. Since we are talking about cooling, क्योंकि बॉडी का टेम्परेचर ज्यादा है, सराउंडिंग का कम है, टी फाइनल पक्की बात है कि टी इनिशियल से क्या होगा? कम होगा. What about the denominator? Time always increases. What about t minus t naught? It's a positive number, and therefore remember this b is negative, is not a positive constant. So this dt by dt which is the rate, is basically negative. And it should be negative because temperature of the body is continuously decreasing. Put on this, make a cross, and then plot a graph of rate of cooling with temperature of the body. Rate of cooling and temperature of body. Between these two, plot a graph, and once I give you the answer, and if you have done the same thing, you will write yes in the comment box. Put down this much. Let's see how many of you can draw a graph. We need to draw a graph between rate of cooling and temperature of the body. Now, if you ever find these things difficult, always do this. This is y, this is x, and we need a graph between y and x. This is y, x, bt minus bt naught. What is the look of this equation? Y equals to mx plus c. What is this? Equation of a line, straight line. This is equation of a straight line, then line, option A, line, option B, line, option C, line, option D. Which option is correct? A, B, C, D. If I plot a graph between dt by dt, then which option out of these four is the correct one? Answer this. Only few responses. What is this C? This C is called intercept. Intercept cut on the y-axis. C is minus of bt naught, but b itself is negative. Negative, positive is coming a positive thing. If it's coming positive, that means this graph is not possible. This graph is also not possible. Graph is passing through origin. Intercept is negative. These two, fight is between this and this. They both have positive intercepts. This will be decided by m. What is m? B, which is a negative number. But what is m? M is tan of theta. Tan theta is coming negative. That means theta is obtuse. If theta is obtuse, what is theta? Theta is this angle. This is theta. This is theta. Which you can see is obtuse for graph C, and therefore correct graph is C. So this is one of the short answer type profiles for school and objective examinations. Well, only there is no need for me to answer how many of you have done this, because all those who have written C, they only could get the correct answer. But I hope everybody understands how to find, how to plot a graph between given quantities. Note down this. Now, we have identified shape of the graph, but question is not complete. Let's see if you can answer the next part of this thing. Hopefully everything is done. Now, look here. This is dt by dt. This is t. I told you this is the shape of the graph. Shape of the graph. Now, this is the shape of the graph, but which part of this graph I should keep? Upper portion, lower portion, both? What do you think? This will develop a habit of understanding these methods. If they ask you a question in an objective examination and they have given you 4 options, you can yourself decide by using certain logic that which option is correct. Certain logic. उतना होना चाहिए ना, बिना उसके कुछ भी नहीं. So this is a graph. We have found out with the help of slope and intercept that this is the shape. But now I am asking you which part of the graph one should keep for Newton's law of cooling, the upper one or the lower one or the complete portion. What do you think? But many of you have answered correctly. Broken part means we are not interested in this. And do you know why? I'll again ask you, the graph which you see on the board, for the graph is running from A to B or B to A. Tell me this. The graph is running from A to B or B to A. And this B and this B, they are different, okay? Just A and B are just 2 points on the graph. And I'm asking you, the graph is running from A to B or is it running from B to A? Good. This graph is running from B to A. Why? Because T is decreasing. Newton's law of cooling. Temperature is decreasing. Now, who will tell me what is the temperature at point A? What is temperature at point A? Write down this fast in the comment box. What is temperature at point A? Good. बहुत सही. Temperature at A is T naught. Temperature of the surrounding. Why? The moment your T becomes T naught, T minus T naught becomes what? 0. जैसे ही बॉडी ठंडी होते होते सराउंडिंग के टेम्परेचर पर आ जाएगी, T minus T naught will become what? 0. That means what? Rate of cooling is now 0. Rate of cooling is what? 0. So the graph, its shape is this, is running in this direction. And right at this point, we have T naught, which is the temperature of surrounding. This is the complete form of this graph. Those of you who could not answer certain points in this thing. If you understood each and every part of the analysis, if you are comfortable with everything, write down yes in the comment box fast. Now, write down a question. Temperature of a body decreases from 60 degrees Celsius to 55 degrees Celsius in 2 minutes. 60 to 55 in 2 minutes. Temperature of surrounding is 30. In what time temperature is going to decrease from 55 to 50 degrees Celsius? What is the question? For a 5-degree drop, 60 to 55, 5-degree drop, it takes what, 2 minutes. Temperature of surrounding is what, 30. In what time temperature is going to further drop by 5 degrees, 55 to 50? And assume that we have to apply Newton's law of cooling. Although you can see that temperature difference, the surrounding is large, but take this difference small and find me the time. Well, there is a very little chance that any one of you can answer this thing, but let me see. I'll be very happy if even a single person can answer the whole thing correctly, or even 80-90% correctly. If the shape which you produce, shape of the answer is very similar to the one I'm going to present, even then I will be very happy. Let's see how many of you are going to attend this thing. I'll give you around 1 minute's time. Look here. dt upon t minus t naught. This is t and this is t. We need relation between t and t, and then we can answer a question like this, which means we have to integrate this. Well, can you integrate this left side? If you can integrate the left side, then write down the answer in the comment box fast. As far as right side is concerned, b is a constant. Integration of dt is what? T. Plus constant of integration c. The c is the constant of integration. I want you to integrate this. What is this? This is dx whole divided by x minus some constant. Temperature of surrounding is going to remain constant and temperature of body is going to continuously decrease. So I'm asking you an integration of dx upon x type. And not a single person has answered anything. Well, have you seen integration of this type? Dx upon x. Have you seen ever an integration of this type? No response. Only one person says yes. What is the integration of dx upon x? ln x log x base e. भाई ये आना चाहिए, मैथ्स है, ये नहीं आता अगर तो फिजिक्स डिफिकल्ट लगेगी. फिजिक्स की वजह से प्रॉब्लम क्रिएट कम करती है कई लोगों को इन चीजों की वजह से ज्यादा. एंड वी हैव ऑलरेडी डन दीज थिंग्स, these integrations and all. So what is integration of dt upon t minus t naught? ln of t minus t naught. If you have given me an answer in terms of log, and I said that shape of the answer, if it is similar to what I am going to produce, so the answer is going to be in terms of log. So ln t minus t naught is bt plus c. This is coming from this. Now, once you get this ln of t minus t naught bt plus c, what it tells us, there are two things which you can do. The first is we have found a relation between temperature of body, surrounding, time. C is what? Constant of integration. Look, log t naught b 0 plus c. When time is 0, temperature is what? 60. When time is 0, temperature is what? 60. When time is 0, temperature is 60. This immediately gives us constant of integration. Then, again, what is this? When time is 2 minutes, temperature becomes what? 55. T becomes 55 when time is 2 plus constant of integration. In this, you need to put all the values. What is C? You already have the value of C. So once you put value of C, you basically get what? Value of B. Now, log of 50 minus 30, log of 50 minus 30, B you already got from this, into T plus C. At what time temperature is 50, 55 to 50. At what time temperature is 50? B you can find from this. C you can find from this. Put the value of C, put the value of B, you get the value of T, but that T is not the answer. But that T is not the answer. Who will tell me if this is T and if we find the value of T, then what is this T? Try to understand the question. This is T. If you get this value of T, then what is the value of T I'm asking you? What was the question which I gave you? Go and see the question. What is this T? And things are a bit mathematical. लेकिन सीखना पड़ेगा. Let me tell you everything fast. Is there anyone who can answer anything? बहुत सही, good. One of you has answered correctly. The answer will be t minus 2. Oh, say good. What is this t? I mean, that means a good thing. I mean, there are people who can answer these basic things. Then, अच्छी बात है. फिर मुझे it basically increases my confidence that I should give you more of these profiles. What is this whole thing? This tells you that when temperature is T, at that moment time is what T. So when temperature is 50, right at that moment time is what T. So whatever time you get from this and this, they are not same. What is this time? The question says in 5 minutes, in 2 minutes, temperature drops by 5. In what time temperature drops from 55 to 50? That means what? थोड़ी देर के लिए इधर देखना. Suppose यहाँ से आपने solve किया and then this t comes as 5 seconds. It tells you what? After 5 seconds, temperature कितना है? 50. After 5 seconds from the beginning. This 60 corresponds to t equals to 0. So after 5 seconds, temperature is 50. But what is the question? Question is कि 55 say, you can take second as minutes because everything is in minutes time-wise. So after 5 minutes, temperature is 50. After 2 minutes, temperature is 55. From 55, 50, कितना टाइम है? यार बच्चों के खेल है 5 minus 2, which will be what? 3. So you need to put values of t, then you get b and c, two unknowns. The third thing says find out time. So the time which you are going to get from this, now let's call this time t dash so that you can avoid any confusion. Your t dash will be t coming from this minus 2 minutes already gone minus 2. We'll develop a shortcut method for this in the next class. But do you understand this profile, this calculation part, although it deals with integration, but not a big or difficult integration. With practice, and you need to do a lot of practice of these things, there is no way you can escape all these things. Well, you can escape all these things, then you are left with only board examination type of thing. So, are you comfortable with the whole calculation part? Do you understand everything? Yes or no? Write down fast in the comment box and then you can leave. Thank you very much.